Hi students, this is also from the fourth unit. I'll be dealing with you the concept of supercharging and turbocharging. This is a word which you have been familiar with it, especially turbocharged diesel engine is very common in most of the diesel engines, diesel cars which are running on the roads. So we should learn about supercharging, which was earlier first introduced. Now only the concept of turbocharger has come. And people are not using supercharging in ordinary commercial vehicles, and we should know the reasons for that. So the supercharging and turbocharging in IC engines is the topic today. Now, why supercharging? Why we have to go for supercharging? What is supercharging? Why we should go for that? So supercharging, I'll talk about it, why we need to go for that. Turbocharging, why we need to go for it. So for example, an engine is running at 10,000 RPM, which is normal. That means a revolution per minute. One revolution is 2 strokes. So that means 20,000 strokes per minute. There are 20,000 strokes per minute. If you divide it by 60, you have 33 strokes per second. In a second, there are 333 strokes. You remember at what speed things are happening. If it in that sense, one stroke is taking just 0.003 seconds. So suction stroke, we talk about suction stroke, piston moves from TDC to BDC, and inlet valve opens and the air is aspirated into the cylinder, we say that way. But you see how much time it is allowed, 0.003 seconds. So that is very small, 3 times of 1,000 seconds. That is only for 10,000 RPM. And when you accelerate, it goes to 20,000 RPM also. Then you can understand how much time is allowed for every stroke. It is very small. So normal engine takes in air by natural circulations. So you can see as the piston moves from TDC to BDC, the volume increases and the pressure decreases. The zero is your atmospheric pressure. Zero is your atmospheric pressure. So you can see that a suction is taking place at a pressure lower than the atmosphere. Just we suck in. Just we take the cool rings using a straw. So we create a low pressure inside the mouth and the cool rings comes into our mouth. The similar way, suction stroke creates a low pressure and air is aspirated into the cylinder. And the time is very small. If air is not taken, sufficient air is not taken for combustion, combustion will be inefficient. A lot of pollution will occur. We need enough amount of oxygen inside the combustion chamber to have a complete combustion. So what is done in supercharging or turbocharging, which we will talk about later. Supercharging or turbocharging, it is a forced induction system. So the pressure is no more below atmospheric, it is above atmospheric. So the air is pushed into the cylinder. Instead of the vacuum pulling the air into the cylinder, the air is forced into the cylinder by means of a compressor, blower. That is what is called as supercharging. So more amount of air is taken into the cylinder, more amount of fuel can be burned, more amount of power you'll get. That is why it is supercharging. Do you understand? Okay, we'll see. And supercharging is not used. Why? Because following reasons. Aircraft and racing vehicles only we use it. Because for supercharging, to run the compressor, we have to give mechanical energy. And that mechanical energy has to be taken from the cylinder itself. So large amount of power is required. And power is wasted. The power developed in the cylinder is used to run a compressor. So a lot of power is wasted. And more power is needed. Supercharging is used in aircraft. Basically, at higher altitudes, the pressure is low. The amount of air is low. So there we need supercharging, but not for ordinary vehicles because it consumes more fuel. Supercharged engine consumes more fuel. That is why it is not used in ordinary vehicles. our commercial vehicles. Because commercially we look for efficiency. 1 liter petrol, you should get more kilometers. That is how we look for it. So supercharging is meant for racing cars, aircrafts, especially warplanes, and if you need more power for the given capacity, the capacity is very important here. So for example, race bikes, they say 500 cc, 500 centimeter cube is the cylinder volume fixed. So how can you get more power from a 500 cc engine? That is the question. Then you can go for supercharging, not for ordinary cases. But you can understand. So that is why it is not quite often used. What is supercharging? It's an air compressor that increases the pressure and density of air. Pressure means density of air. So compressed air is supplied to the IC engines. So more mass of air is supplied. More air is supplied, more fuel can be burnt. So more oxygen, intake has more oxygen, allowing more fuel to be burned, and you'll get more work, that means more power. That is the purpose of supercharging. That is the word supercharging. Charging more. Charging is supplying more fuel. That is possible because you can supply more air. But the problem is the power for the supercharger. The power to run the compressor is provided mechanically by means of a belt from the engine crankshaft itself, from the engine itself. So you are losing major amount of power to run the compressor. That's a problem in supercharging. So to overcome that problem, the modern development is turbo supercharger or turbocharging. You can sometimes they used to call it as a turbo supercharger. Now they are simply calling it as a turbocharger. So instead of taking the power from the engine, they are trying to develop power by means of a turbine using an exhaust gas. So exhaust gas is going through the silencer to outside. It has a velocity. It has a velocity. It has a pressure. So supercharger is known as turbocharger, is nothing but it is powered by the exhaust gas. Gas turbine. A gas turbine produces the power. So instead of the difference is instead of mechanically driven, now because that is less efficient, so we will be using the turbine, power produced by the turbine using the exhaust gas. But the problem, you can see that the turbocharged technology is now used in almost all diesel vehicles. So the problem with turbocharging is at low speed it doesn't work because you should have a proper velocity for the turbine to rotate, because the turbine uses the exhaust gases which is coming out of the engine. So that should be sufficient enough. It should have the sufficient velocity, sufficient quantity enough to run the gas turbine. So turbine is a device which produces mechanical energy. Compressor is a device which consumes mechanical energy. So the power produced from the turbine is given to the compressor, and the compressor compresses the air and gives to the engine. That is the principle. So both are coupled together, turbine and compressor. Turbine produces mechanical energy, and the input is the exhaust gas. And that shaft, mechanical rotation, is given to the compressor, and it compresses the atmospheric air and gives during the suction stroke. So that is how a turbocharger works. And turbocharger is more popular because it gives better efficiency. And those who are using a diesel vehicle can feel it. Once the vehicle goes beyond 80 kilometers per hour, then the turbo will take over. And in highways, you can see the vehicle speeds up. It gives better power. The turbocharged vehicles will give better power once you can feel in highways when you go beyond 80 kilometers per hour speed. And now in Volkswagen, they come up with the technology in which they have both supercharger and turbocharger. Because the problem with turbocharger is it doesn't work at low speed. So they were thinking about at low speed, they use the power of the crankshaft. So it is a supercharger. Once the vehicle attains the speed, the turbine operates and it becomes a turbocharger. So that is also possible. Nowadays it is coming up. So what is a turbocharger? So turbochargers are driven by the waste exhaust gases. So for the turbine, in another way to remember it easily, turbocharger uses the turbine power. And the turbine runs by means of the waste exhaust gases. The amount of power is depends upon the speed and that will be manifested in the exhaust pressure. So that is needed. So this animation gives a very clear picture about it. You can see that this is your engine and you can see the exhaust goes this way, and this exhaust gas, when it has a higher velocity at a higher speeds, it goes past the turbine. So this is what we call it as a turbine. So it produces a mechanical shaft rotation, and this goes out to the atmosphere, exhaust gas, after doing the work on the turbine, after rotating the turbine blades. So this mechanical shaft is given to the compressor. So the compressor starts to rotate, because compressor is a device which needs mechanical energy and it can compress the fluid which is flowing through it. So it takes the inlet air at low pressure, compresses it to a higher pressure, and it gives to the engine. So this is how the turbocharger works. The exhaust waste gases runs the turbine, and the power of the turbine is going to the compressor, and it takes the fresh air and supplies it at a high pressure to the cylinder. So this schematic also represents the same way. You have a turbine section is there, where exhaust, the red is exhaust gas, and you have a compressor section. So you have a turbocharger has both the sections. So the turbine gives the mechanical energy for the compressor. When it is a supercharger, these portions will not be there in a supercharger. Instead, you have a belt to drive. Power from the crank is given to the compressor. That's the difference. So that is how it works. We have seen how it spins and other things. That is how the turbocharger works. So I'll just try to conclude it. So supercharger and turbocharger, the advantage is more air is taken in, more fuel can be burned for the same existing cylinder capacity, and more power can be obtained. But the problem with supercharger is it consumes power from the crank, whereas the advantage of turbocharger is the power is developed by the waste exhaust gas. So that's an advantage. Thank you for watching. Go through it. This is an important portion in this unit. They can ask, explain supercharger and turbocharger and its advantages. Hope you can do well. Thank you for watching. Have a nice time. God bless you.